Hey, hello, physics students. I have a question on chapter 18, number 22. And it's really talking about the power of the lens. And I didn't get a chance to say too much about it in the video lecture, so I'll say one extra thing, and then the problem you'll see is pretty straightforward. Let's just say that we have one lens that has just a little bit of curvature, but a second lens that has a lot of curvature. Because of the refraction property, the light coming in, and I'll just draw three beams of parallel light, will hit this lens. It'll refract off the front surface, refract again off the back surface, and this is called a converging lens because it makes the light converge. It's also referred to as a convex lens because of its geometric shape. But it would make the light come to a focal point. So we call this the focal length. How far is this point from the lens? Of course, I guess the light continues on out. So after the focal point, it'll look like it's diverging. But when you compare it to one with more curvature to it, so I'll draw three lenses or three beams of light here, it's going to hit the front surface and refract, and for that matter, the back surface and refract. And those two refractions are going to be greater than up here because the amount of refraction, the amount of bending, depends upon two important factors. One, we said, is the speed difference, and so I'm kind of implying this is made out of the same material. So that's not the reason why. The other one is the angle, and so the greater the angle, the greater the bending, and so these will bend more. And so what will end up happening is the lights will have also a converging effect. But this conversion will happen in a much shorter distance, and so its focal length would be less. So maybe if I called this focal length number 1, and over here focal length number 2, I would say focal length number 2 is less than focal length number 1. But the idea is kind of still the same, that it is a converging lens, or a convex lens, and it makes the light converge. Okay. Now, you might then say that lens number 2 is stronger. It has more power. Now, it has a smaller focal length. And so what we like to define is the power of the lens. The power of the lens would mean that my strength or my focal length is smaller. So we define the power of the lens as 1 over the focal length and measure it in units of what's called a diopter. Now, it's equivalent then to a 1 over a meter. And so you take the distance in meters for the focal length, you take its reciprocal, and that's called the power of the lens. For any of you who go to the eye doctor and you get an eye prescription, they'll often do, something like this: right eye, left eye. And in my case, my prescription is, what is it, negative 1.75, I believe, in one eye. And my left eye used to match, but I think it's a little more now. Negative 2. But let's just talk about my right eye. What they're saying here is this is the power. Meaning, to correct my vision, if power is the reciprocal of the frequency, the focal length, doing a lot of wave ones from the previous chapter with you guys, and I got frequency in my head. But focal, I'll just take the reciprocal of the power. So doing my right eye, if I were to take a 1 and divide it by 1.75, I would then need corrective lenses that has a focal length of negative, I should talk about that, 0.57. So it is a distance of about a half a meter. Now the negative is there for the diverging lens. If you needed a lens shaped like this, which is for farsighted, you would have a positive out in front. Most people are nearsighted and need a diverging lens, and so most people have a negative in front of their prescription. But you could have farsightedness. In fact, it's a side note, I kind of wish I was farsighted, not nearsighted. Each of them have their slight disadvantages, but you see, if you were farsighted and you had a positive lens, remember that when you look through this type of lens, things that are close would look bigger. So somebody looking into your eyes, they look through your glasses and they look to your eyes look bigger, which gives kind of a warm, friendly approach, because a negative lens makes your eyes look smaller. And so that makes you look mean and beady-eyed. And so that's how people can perceive you as they look through your eyes through your glasses. Everything looks small and you look angry and mean, even though I'm not. I'm really not an angry and mean person. Okay, so that being said, let's go ahead and actually do this problem. It says here, if a lens has a focal length of 12.5 centimeters, so 12.5 centimeters, the key step, though, is to make sure you change it into meters, because the power is the reciprocal when you're in meters. That's how it comes out to be diopters. Is that an 8? That must be 1/8. 1 divided by 0.125 is 8. So this would be 8 diopters. And there. Hope that helps.